Okay, let's do this last lesson. So today we're going to be talking about having two functions. Right now, yesterday's lesson we had one function, but we were revolving this region around this one function. Right, we're revolving the region around a line other than the x-axis or the line y equals 0. So today we're going to do the same thing. It may be around the x-axis, around the line y equals 0, but it may also be a line that's above or below this region. Okay, so let's look at this first one right here. So find the volume of the region in the first quadrant enclosed by the y-axis and the graph of cosine x and the graph of sine of x. And in this first example, we're going to revolve this around the line y equals 0, or otherwise known as the x-axis. Right, so let's do this. So first of all, you're going to go ahead and make sure you know what you're talking about. So you may need a graph, right? So first of all, we are looking at a the y-axis. So we're talking about this line right here, y-axis, cosine, which is this top one right here, the red one, and then sine, which is the bottom one right here, right? And we want to do in the first quadrant, which is over here. So first quadrant, okay? Because if we didn't say the first quadrant, okay, we could also be talking about the y-axis, the graph of the cosine, which could be also this side, and then the graph of the sine, which is this bottom. So it could also be right here, but this is in the second and third quadrant. So we don't want the second quadrant, and we don't want this third quadrant. So we only want the stuff in the first quadrant. So we're gonna have to utilize the other one, which I had earlier. Okay, so we're talking about that little triangular piece, which isn't really a triangle, right? So we're talking about that piece right here, okay? And we want this area right here, revolve around the x-axis, which is this line right here. We're going to spin it around the x-axis. Okay. So in order to do that, okay, you can imagine that as it spins around, it's going to kind of make this three-dimensional shape, right? Now that's not a Pac-Man, that's two-dimensional only. Okay. But when we spin it around, it's going to create that shape right there. Okay. So if you're looking at it, it just kind of looks like this. Right? It just kind of looks like that, and like that, and like that, and then front it just looks like this. So on the outside, that's all you see. Okay, kind of like a pot, like a pot or a vase for, but inside it's gonna be hollow. Okay? It's gonna be hollow, and it's gonna be hollow to a point like that. So that's what it looks like. Okay, and what we're gonna do is we're gonna cut a slice out of it. Okay, so we are gonna cut a slice out of that. It doesn't matter where you cut it. But when you cut it, you'll see that you have an outside piece, an outside disc, and then you also have an inner piece, an inside disc, which is going to get cut out. That's where the hollow is. That's where it's hollow. Okay. So really, we're looking at that shape, or what we call a washer. Okay. And yesterday, I already introduced you to a washer. Okay. You can create a washer from having revolving your axis of rotation around a line that is other than y equals 0, or the x-axis. Okay. Now in this case, since we have two functions, it will also create a washer or a donut. And now, as with a washer or donut, we talked about this on the other video. Okay, you need to find out the area that's in between these, right? Because if the inner circle is hollow, then that means that you really are just looking at this area right here. Which means that you need to find the area of the whole thing, which is all of this. And then you need to find the area of the inner circle, and you need to erase and you need to delete that, which means you're subtracting it. So all in all, you're going to be taking the area of the outside circle, and you're going to be subtracting the area of the inner circle, which means that you need to find the radius, and we call this the big R for the radius of the big circle, and little r for the area of the little circle, okay, or the radius of the little circle. Okay, now big R, if you think about it, and using blue in this case, it's going to be from the inner to the outside. So that's big R. So from the inside all the way to the outside edge. And the outside edge, we're talking about this one, the outside edge of this function is that red function, which happens to be your cosine function. So big R is just cosine of x, okay? Because we're measuring from the x-axis up, and that's your y value. So the y value happens to just be cosine of x. So big R is just cosine of x. Little r, we use red on that one. Little r is going to be from the inside to the outer edge of the inside circle. So in this case, it's going to be this part right here, where I'm doing in red, right? And that line right there, that is your sine of x. So that's your y value for your sine of x. So little r is going to be just sine of x, because we're measuring that distance y from the x-axis up. Now, if we had a different line of rotation, then that means that we might have to add 1 plus the sine of x. If we had a different line of rotation, then we might have to do 2 plus sine of x. But in this case, we're just coming straight up from the x-axis, so we don't need to do that 1 plus or 2 plus or whatever. Right, so now we're going to go in and write our equation for the volume. The volume is equal to integral from a to b of the area. The area is a cross section composing of the big R area using the big R squared, pi times big R squared minus, and then pi, the area for the small circle, pi times little r squared. In this case, I'm going to be using this function right here, big R and little r. Now, one thing that you might have to figure out using a calculator or Desmos or whatever program that you might be using is you might want to figure out where these functions are going to be intersecting, right? Because the only place that if we go back to the beginning, let's go back to the beginning and then backtrack this. So very beginning, right? You might notice that, yes, we know that this region starts at 0, but it doesn't end at 1. It ends at an unknown amount. So in order for us to do this, we're going to have to utilize our calculator to help us. Okay, so we're going to use our calculator to help us figure out where the intersection is. So using our calculator, the intersection, okay, you're going to go ahead and go to your graph, and you're going to go ahead and graph cosine of x, and you're going to also graph sine of x. Okay, you're going to do a zoom, and we want to do a zoom 7 because we're talking about trig functions. Oops. So you can hit enter, or because my thing is blocking it, I'm just going to hit 7. So it's going to go ahead and trace out my cosine, which is the right one. You can see it hits the top, and my sine, which kind of hits the middle. Right? And we want to find that intersection point right here where my arrow is. So you're going to go ahead and do a calculate feature. So hit second and then calculate. And then we want that intersection, which is option 5. Okay, so I'm going to type in 5, and it's going to ask me, or actually I'm going to move this over just a tad. Okay. It's going to ask me where my first curve is. Okay, so you see that first curve right there, and it says y1 equals cosine of x. So you can move to y2, which is the sine of x, but I'm just going to leave it as y1. Okay, and it doesn't matter as long as you're picking 2 different curves. So first curve is going to be that right there. Second curve, you can see how the cursor moves to the second, to the sine graph, and now it says y2 is sine of x. You're going to hit enter. Okay, and those are important that you pick either one or the other at a time. But the important part is your guess, okay? Because you can see on here that they're going to intersect over here. Yeah, so you click over here, it's going to give you that intersection point, probably about right there. Okay, or you go a little bit further, you'll see that's going to intersect over here as well. And we don't want any of that. We want the one that matches our diagram on our notes. So we want the one that's over here. So you want to go as close as you can. So my guess is 37.5, and I'm going to hit enter. It's going to take a moment to think. You can see it moving up here. It's thinking. And now it tells you the intersection is x is 45. Wow. I don't think that's right. Oh, I know why. Because I'm in mode degrees. 45 degrees. So actually, I want to go back to radian mode. Okay, so let's rezoom that. Zoom 7. So I have to do this again. I'm sorry. Okay. And we're going to go ahead and do a second calculate, and then we're going to go ahead and find the intersection point. So hit second. You missed the first time around. Calc. Option 5 for intersection. First curve, I'm just going to hit enter. Second curve, I'm going to hit enter, and then oops, enter, and then now it's going to be yes, and I'm going to move close to where that is. Okay. I'm going to hit enter. And you can see on my graph here, when I graph it, it's pretty close to 1. It's not 1, but it's a little bit less than 1. So when I had 45 earlier, I know that's where I messed up because my mode was wrong. So you hit enter. Let's give me the intersection point is about 7.78539816, which does look like it matches this. So that's my intersection point, and I'm going to go ahead and write that down on the side somewhere. But if you know that that intersection point, 0.785, 0.7853, okay, that right there is a pi divided by 4, I believe. Okay, so that right there, that's actually pi divided by 4. Okay, so all my notes right here. So now we know that intersection point of those two spots is actually 0.73, whatever that is. Right? I'm just going to put in pi over 4 because that's how it's easier for me to memorize it that way. So that's going to be intersection point. It's going to be pi over 4. Okay. So as I go through all of this, okay. So my lower limit is 0 and my upper limit is pi over 4. And then I'm going to use the pi big R squared minus pi little r squared. And remember, we already know that big R is going to be my cosine of x, and my little r is going to be my sine of x. Right, so in this right here, my big R is going to get replaced by cosine of x. My little r is going to get replaced by sine of x. So I will have, and then I'm going to move the pi to the outside because pi is a constant which can be moved. So you're going to, in your calculator, you're going to type in pi times integral from 0 to pi over 4 of cosine squared, or cosine x quantity squared minus sine x quantity squared. And in my notes, okay, I'm going to have the answer of 1/2 pi, or pi divided by 2. Right? So now how would you put this in your calculator? You obviously, a lot of you guys are not very familiar with the trigonometric functions and the unit circle, so you're going to have to figure out, okay, well, what is this answer? Right? So if I go into my calculator, okay, so I'm going to first put in pi over 2 just to show you that what we're going to get is the same thing. So pi over 2 is equal to 1.570796327. Right? But what we're going to do is we're going to go ahead and we're going to put in this integral, right? So we're going to type in pi, and then integral is found under the math feature. Go down to option 9 for finite integral. So pi, finite integral, you can hit times if you like, right? So like right here, if you want to put a times, you can second insert and then times if you like. If you want to keep it like that to make it a little bit more tidier, it's up to you. I'm going to type in the function, which is cosine x quantity squared. Oh, but look, I already have this up here. See, cosine x is already y1. So I can actually just put in, well, let's try this, right? Let's try cosine, and because cosine x is going to be squared, I need to actually have a parenthesis. So I know when I type in finite integral, it already has a parenthesis, but I need to put in my own parentheses. And I type in cosine, which already has another parenthesis. I know it's getting a little confusing now. Just watch what I'm doing. And you hit X. Now you need to close that first parenthesis. Okay, and you need to close that second parenthesis, and now you need to square that because we want the entire amount of cosine x to be squared. If you don't do the second parenthesis right there and you're just squaring it, you're actually just going to be squaring the x, and that's not what we want. We want to square the entirety of cosine x. Okay, and then we're going to go ahead and subtract, and we're going to do the same thing. Parentheses, we're going to hit sine. Sine already gives you an x, or a parentheses. You're going to put x, you're going to close that parentheses, you're going to close the parentheses around the sine, and you're going to square that. That's how it needs to be put in, like that. Okay, and then now you're going to do comma, x for the variable, comma 0 for the lower limit, comma, and then you can type in pi over 4 or that 0.7 blah 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 that we just got. You might remember right there. 0.78539. You can type in all that if you like, but you make it easier. I'm just gonna type in comma and then pi divided by 4. Close that parentheses, and you will get, see, same answer. Right. So I know my answer in my right here. The answer says it's 1/2 pi, or basically 1 times pi, which is pi divided by 2. So the answer is pi divided by 2. So I'm showing you that pi divided by 2, which is right here, is the same is 1.5707, and when we did all of that, you get the answer of 1.5707. And if you didn't know what pi over 2 was, it's okay. You would just write in the answer of 1.570796, or just whatever you want to round to. Okay, I'm going to show you another way if I use the y1 and y2. So I'm going to go ahead and type in my pi first, times. Actually, I'm going to show you that you don't even need a time. So I'm going to hit math. We want to do the finite integral, and then we're going to do the y1 because I know y1 is the cosine, and in this case, y1 is the big R, cosine is the big R. So I'm going to go ahead and do y1. That's going to be found in the vars, or variables, and we want y variables, and we don't want parametric or polar. We want function, which is our regular function, and we want y1. So that's going to be y1, and we're going to go ahead and square that. So if you do it this way, there's less mess, there's less parentheses you can screw up with. And we're going to go minus, and then y2, which is another variable, or another y variable. So vars, y vars, enter, and then we want y2. Don't hit y1. We want y2 this time, and we want to square that. And hit comma, x, comma 0, comma, and then we want pi divided by 4. Close that, and you'll see it's the exact same answer. Okay, 1.57079. Okay, all the numbers are the same, so which is equivalent to pi over 2. All right, so that's pretty much the lesson. The only thing that gets harder is your axis of rotation. In this case, we are rotating or revolving this around the x-axis. Right here, that little, back when I was still a student, I used to think this was a G. I used to think my teacher, Mrs. Zamora, okay, not our Mrs. Zamora, but my teacher, Mrs. Zamora, thought he was drawing G's up there. But there are actually arrows that goes around that shows you that that's your axis that you're revolving around. Right? So try that with the assignment today and see how that goes. All right? So any questions? We'll talk some more.